Hello there, and welcome to the first module of the science course. And just as a reminder, the modules are the tabs that you see here on the notebook. So the first one that we're going to be looking at is scientific inquiry, which I just called inquiry for space. So if you go to that section of your notebook, that's actually page 5 in your notebook, and the page numbers are down at the bottom corner. Let's see if I can pull that in there. You see the 5 there under that bottom tab. So this is page 5. This is the cover for this module. And if you want to put tabs on it, like my notebook, that would be a perfectly good idea. However you want to use it is fine. But I am on page 5, and we're moving over to page 6. This is the page that we're going to cover in this video. And I highlighted for you the terms that we need to talk about. I would strongly recommend that you make yourself some flashcards with these terms. One of the things about most science tests that is very difficult is the vocabulary. So the better vocabulary skills you have, the better you're going to do on science exams. So one way to build vocabulary that has definitely worked for me as a person with dyslexia, this worked for me very well, was to get some flashcards. I would advise you to get some yellow ones, the color of legal paper. The pale yellow, if you have reading problems, can sometimes be very helpful. So I would suggest writing these terms on one side of each index card. So on one card you write conclusion, on another card you write control, and then the definitions that I'm about to give you would go on the back sides of those cards. Also, if you are following along in the textbook, I've given you the page numbers up here at the top, pages 18 to 21, and let me remind you again, the textbook looks like this. So if you have that from your teacher, or if you've bought that yourself on Amazon, you can follow along with me. There's a lot of good information in this book. Okay, I'll stop talking about that and let's look at these terms. You will notice that the terms are in alphabetical order, but I'm not going to go in that order to tell you about the theory of these terms. There's a logical order, and it's not the alphabetic one. So we'll be jumping around just a little bit. I do want to tell you also that once we get out of this first module, we will not be writing terms over and over. For the first few lessons here, we just have a lot of terms that we have to plow through. But as we get on over into some of the other modules, you will start to see diagrams, charts, and graphs and things. You do see some terms still in there, but we will be looking at things other than just writing definitions. So if you don't enjoy that, please don't give up on me just yet. I promise it will get better. But for this first part, we just have to plow through. So, okay, if you are on page 6, we're looking at this list of terms that relate to investigation design or experiments. If you go on to graduate school, you will be doing experiments, and you have to know how to do them correctly. So we're laying some foundation. Also, most science tests are going to have experiments in the test. You read about the experiment, and you need to know what these words mean to be able to understand. So, I want to start with the word observation, because that's where science starts. If you're a scientist, you are an observer of the world around you. So, scientific experiments start with observation. And here's the definition of observation. It is information gained or gathered. Let's use the word gathered. Information gathered through the senses. And so I would ask you if you can name your 5 senses. How do you gather information about the world around you? Well, or let's use an example of how does a cat gather information about the world around it. One of the first things a cat can do is smell very well. So the sense of smell. They see things. So I'm just going to say see. They smell, they see, they hear. They taste. Cats can tell the difference between tuna and cheese very well. They have a good sense of taste. And the other one, this is the reason I like to use the analogy of the cat. What do their whiskers do for them? That's their sense of touch. They can tell about temperature. They can tell about lots of things by those whiskers. That gives them a sense of the world around them. So just like cats, we as humans have those 5 senses, and that's how we observe the world around us. So science begins with observation. And so let me give you just a practical story. I like to tell you stories as we go along to illustrate the point I'm trying to make. So let's say that I observe that people who drink a certain type of soda are losing weight. Okay, so I watch maybe some of my friends and I realize they switched to this diet soda and they're really losing weight. So I would come up with a hypothesis. And here's the hypothesis definition. Hypothesis is a prediction or an educated guess, not a stab in the dark. It's a prediction or an educated guess about the answer to a question. So in my story, my hypothesis is this. I predict that people who drink Diet Coke will lose weight. Do I know that for certain? No. It's a prediction that if you give people diet soda instead of regular soda with sugar, they're going to lose weight over time. That's a hypothesis. It's a prediction about the answer to a question. And hypotheses can be tested. That's the purpose of an experiment, is to test a hypothesis to determine if the prediction is supported or if it's refuted, if it's contradicted. So I observe, I make a hypothesis. The third thing is investigation design. I set up an experiment. And an investigation design is a procedure. And you'll learn the procedure in the next chapter, next lesson. But it's a formula, it's a step-by-step procedure. Designed, it's given a design. You have to think about that design carefully to answer a specific question. So in my story, my specific question is this. Do people who drink Diet Coke lose weight? That's the specific question that we want to answer. We observed that this could be true. We made a hypothesis, and now we're going to make a procedure to test that question. So to set up an experiment, you have to have variables, and this is the very last term. A variable is a factor that changes in an experiment. Okay. So for example, in our story, the variable, or one of them, will be the type of soda. So let's say that in my investigation design, I decide I'm going to take 1,000 subjects, 1,000 people. I'm going to give 500 of them diet soda and 500 of them regular soda for 1 year. That's all they're going to drink. That's the variable. It's the factor that changes. Do you get the diet soda or do you get the regular soda? The type of soda varies based on the group you're in. Okay, after you understand a variable, you need to understand a dependent variable. And actually, I'm going to give you independent variable first. Let's go ahead and do that one first. It's a little easier to explain. An independent variable is a factor that is controlled by the scientist in an experiment. So if you think about our story, remember our variable is the type of soda, regular or diet. And so I, as the scientist, would say, okay, I want these 500 people to have the diet soda and the other 500 people to have the regular soda. So that's the factor that I can control about this design. So what's the thing that I, as the scientist, cannot control? What is the thing that depends on the type of soda you drink? That's called a dependent variable. And this is a factor that changes. Remember, variable means change in response to an independent variable. In an experiment. And guys, while I'm thinking about this, there are two things I want to tell you here. First of all, why didn't I just write all these definitions down for you? Why am I having you to write them down too? That is because you remember things that you write down. So I'm trying to help you process this information. If I just give you the sheet and ask you to read it, or even if I read it to you, it's not as effective as having you to write it in your own words, in your own handwriting. But having said that, I do want to tell you this. You don't need to memorize these terms. I just want you to be familiar with them, and you will hear them again as we go through this course. So don't feel like you have to memorize all of this stuff. Okay, the dependent variable in our story is going to be weight loss, weight gain, or no change. So remember, the independent variable, this one, is what I can control. So I'm going to control whether the subject gets a diet soda or a regular soda. What I can't control, the dependent variable, is whether or not their weight will change. So all the subjects in the study may gain weight, they may lose weight, or they may have no change. And that is the dependent variable. It depends on the type of soda they're drinking. Okay, the next one is a control, and this is a very important part of an experiment. A control is a factor, and you may be able to guess what it means. It's a factor that is kept the same or constant in an experiment. And some professors will use constant, some will say the same, but it means the same thing. A factor that is kept the same or constant during an experiment. And in the example of our story, what is it that I have to control to make my experiment work? It's the type of soda. What if somebody in the diet soda group was secretly drinking regular soda. I'm not controlling what they're drinking. If I say, okay, you can drink anything you want to, that is not controlling the experiment. So for us to be able to say that our experiment is accurate and valid, we have to have control. We have to make sure that the diet group and the regular group do not mix, that they don't cross in any way. Okay, the next one is inference. Inference is a statement. So this is something I come up with in my mind. And observation. That include additional knowledge. So let me give you another aspect of our story. Let's suppose that halfway through my experiment, the folks who are drinking the diet soda suddenly start to become sick. They start to have nausea, sick stomachs, start to vomit. What could I infer? Okay. I could infer that they're drinking a lot of this diet soda, and that's all they're drinking. I could know that from past experience, diet sodas have been linked with stomach problems. So I would come up with an inference about that situation, that maybe the diet soda is causing sick stomach. I can't say that for sure. It's just a statement about what I have observed and what I know from past knowledge. Okay, the next one, I'm looking at my list, is error. And you know this one. An error is a mistake. So let's suppose that a week before my experiment ends, I realize that I have been giving the diet group regular soda. That's an error. That's a mistake that would ruin my experiment. Some mistakes are very serious and some are minor, but a mistake, an error, can affect the outcome of your experiment. Okay, the word trial. A trial is one of a number of repetitions. Of an experiment. So maybe I find that in my particular experiment, it does seem to be supported that the diet soda group loses weight. I could try that with another group of 1,000 people, and another group of 1,000 people, and another group of 1,000 people, to see if I get the same results. So trials are repetitions. They're doing the same experiment over and over and over, exactly the same way. And that gives credibility to your results. If you get the same result every time, that lends credibility to the idea that this is really the answer to your hypothesis. And the last one, appropriately, is the conclusion. The conclusion is the solution or the answer to the hypothesis. And generally in science, and my background is in forensic science, so this is especially true, we never say that we prove a theory. We say that we support the theory, or that what we find is consistent with the theory, but you really can't indefinitely answer most questions. You can say that it is very, very likely or very, very unlikely, but you really have to be careful saying that you are sure that this is the solution. So I'm a little bit hesitant to use the word solution, but that's what your book uses, and I'll stick with that. But a conclusion is a statement that something is supported or not supported. So in our story about the soda, I could say that my research shows that the subjects who drink the diet soda did lose weight. That's all I can say. I can't say for certain that that's why. They may have lost the weight anyway. That group may have exercised more. But I can say that drinking the diet soda is consistent with weight loss. Or I may find that there are some people who say that drinking diet soda causes you to gain weight. And our story, our experiment could have shown that as well. But the conclusion is simply the statement about what you found. Does it support your hypothesis or does it not support your hypothesis? But there are lots of different ways to say some of these, and we get in a little bit of difficulty sometimes because there are a lot of ways to say the same thing. So, okay, that's an introduction to investigation design. You've learned 11 new terms here. You do not need to memorize them, but you need to be familiar with them. And I strongly suggest that you practice pages 18 to 21 to help you sharpen your skills with these terms. In the next lesson, we will be looking at a few more terms and also the scientific method. So I'll see you in the next video.